Hello there, this is Learn with Ceri, and congratulations on making it to Quest 4. I hope you found some of this week's puzzles a nice challenge. Let's have a look at some of the solutions. I've chosen to look at a bit of algebra on question 2 and 8 and some geometry on question 4 and the pirates question. Did you get 80? I'll show you how. First, question 2. Some algebra in this one. X plus 2y equals 9 and 5x plus 4y equals negative 4. Then what is the value of 8x plus 10y? So we need to use these two statements that we know are true facts to try and alter them, manipulate them until we've got the value of 8x and 10y. And 5x plus 4y is closer. If we doubled it, then we'd get 10x plus 8y, and that's the wrong way round for our coefficients. If we multiply this one by 3, so we get 3x plus 6y equals 27, and add that on, we've got our 8x, and actually, that's a bit of luck. If we do 4y from here added to the 6y here, then we get 10y. So that's what we're going to do. We're going to take 3 of the first equation and add it to 1 of the second equation. Just write the second equation underneath the first there. Add them together. We've got 8x plus 10y, and the value of this, 27 plus negative 4, is going to be our solution. There we go. Happy days, 23. Okay, on this question, the diagram below, AB is parallel to FG. So we know that BCD is 20 degrees and DEF is 70 degrees, and they're labelled for us. We need to work out the obtuse angle CDE in degrees. Now, I've seen quite a lot of these in my time, so I know that a really good method is to put an extra parallel line on, and then you can use your angles and parallel lines rules. So we can say that this angle over here is 20 degrees because it's an alternate angle in the parallel line. So we've got that little green bit there, we can write 20 degrees there. And similarly on the other side, here we've got co-interior angles. So if this angle here is 70, then the portion below it is going to be 110 degrees. And so the obtuse angle CDE is 20 plus 110, which is 130 degrees. So with that extra red line, made it quite quick to solve. So I hope that's useful for future for you. Let's have a look at question 8, a bit of algebra again. Find the sum of all real values of x that make this equation true. So we've got a value to a power and it equals 1. We're going to have a few values because it wants us to add them up, the sum of all the real values. So we're going to have a few options here. Interestingly, when you take, you probably know this, a base to a power, so the base to a power, I'll put my base in yellow and I'll put my power in green so we can keep a bit of a track of that. So, and the value is 1. It could be that the power is 0, so the index is 0. So let's solve that as our first option. So it could be that 3x minus 18 equals 0, because no matter what's in the bracket, a power 0 is 1. So 3x is 18 and x is 6 is a potential option for x. Okay, that's one way. Another way is 1 to the power anything is going to still be 1. So let's have a look at the yellow bit, the 2x plus 7 being a value of 1. So 2x would equal negative 6 and x would equal negative 3. Oops. And That's an option for us as well. Okay, so is that it? Do we need to just add them up? No, because actually, if you take -1 to a power, then if that power is even, then you'll get 1 again. So let's have a look at that idea. So what if the 2x plus 7 equals a -1? So that means 2x would be -8 and x would be -4. But that's only going to work if the n is even. So let's check that 3 lots of -4 minus 18 is even. So -12 take away 18 is -30. So yes, it is even. So this is also an option. So if we do the sum of all our real values of x, then we've got the sum of is going to be 6 plus a -3 plus a -4, which is -1. And that is the solution to this problem, -1. Okay? Let's have a look at the pirates question. 4 pirates find 18 identical coins in a chest. Here they are. They agree to distribute the coins amongst themselves such that the pirate with the most coins has less than 3 times the number of coins as the pirate with the least coins. In how many ways can they distribute the coins? So I'm going to imagine that we've got A, B, C and D. Now we don't know which pirate has the least number of coins. It could be any of them. Let's go with it being A and think if A had 1, the pirate with the most coins has to have less than 3 times the number of coins, so that would be 2, and that's too many to distribute, and these numbers being 1 and 2 only, they can't be over 2, so 1 is not going to work. And the same would go for 2, because 2, the most would be 5, and then 5, 5, 5 and 2 only makes 17, so that's not going to work either. So 3. So 3 threes are 9, so this one could be an 8. If we've got 3 and 8, that's 11, we've got 7 left to distribute here. So I'm going to keep this as low as possible to have some kind of system. 3, 3, 4, 8. And then this one here, it could also be a combination of 3 and 8 with, oh actually no, it doesn't work, does it? So let's scrub that one and go to 3 and 7. 3 and 7's 10, so we could have 3 and 5 to make the 8, and 3 and 7's 10, and there's also 4 and 4 to make the 18. Lovely. Okay, let's try 3 and 6. 3 and 6 is 9, so we need another 9. We could do 3 and 6 again, and then 3 and 6 is 9, so 4 and 5 could also be an option for 9. And that's it for 3 and 6, so let's go 3, 5, and we need 10, so it's going to have to be 5, 5, because 4, 6, the 6 goes too big. Okay, that's it for the lowest being 3. Let's try 4. So 4 and 11, that makes 15, so they're too low in between. Let's have a think. Even 4 and 7 makes 11, leaving only 7 here, and we can't make 7 with numbers 4 or greater. So let's go with 4 and 6. And if I've got 4 and 6, then I need 8, so 4, 4, and that's going to be the only option for that. 4 and 5, does that work? Yeah, I've got 9, so I can do 4 and 5 again here, and that's going to be it. If I do 5 here, it's going to be 5, 5, 5, 5, which is 20. That's no good. Okay, I think we've got all the possible options there, but we don't know that pirate A is the one with the lowest and D is the highest. It could be any way round. It could be 3, 4, 3, 8, 4, 3, 3, 8. These 4 numbers could be in any order. So actually the way you work that out is there's 4 options for the first, 3 for the second, 2 for the first, so that's 4 by 3 by 2 by 1, or 4 factorial. But because we've got a repeat, we have to divide that by 2 factorial, which is 2 times 1. So that is 12. So that first one's got 12, and so has the second one. And so has the third one, because it's 4 with a repeat there. This one's got 2 repeats, so we have to divide by 2 twice. So there's 6 ways round that could work. And this one's got none at all. They're all different. So that's 24 different ways that those numbers could be arranged. This is a 4 factorial divided by a 3 factorial, which is 4. And this is same again, another 4. And this is the same as the 3366, so that's another 6. So we've got 12, 12, 12, 36. We've got a 24. We've got a 6464, so that's another 20. Just adding this up as quickly as possible. 80. 80 different ways that these pirates could arrange the coins. All right. So all that's left is for me to wish you loads of luck for the final quest of stage 1 next week. Go for it. I hope it goes really well for you. Bye bye.